is Monday 28th of October 2013, and today we're looking at the question that a lot of people are asking at the moment: why is Venus looking so bright? Some people feel that Venus is looking unusually bright and that there's something wrong, and that there's something that the government isn't telling us and all this sort of thing. So we're going to take a look at Venus today and see if we can figure out why it looks so bright at the moment. As you can see, I've got Starry Night Pro set to Dallas, Texas, United States. So this is a Northern Hemisphere view of Venus, and I've set the time at 7:30 p.m. This is daylight saving time, and we can see Venus here in the sky. Now we're looking due west here, so we can see that Venus is in the southwest at 7:30 p.m. as seen from Dallas, Texas. Now sometimes it's hard to actually visualize what's going on as we see things in space, so what I'm going to do is turn on the orbit for Venus, and this will hopefully make things a little bit clearer. Now we can see Venus's orbit around the Sun. Remember that we're the third rock out from the Sun. From the Sun we've got Mercury, then Venus, then the Earth. So we've got two planets' orbits within the orbit of the Earth. So here is Venus, and you can see that this line here is the far side of its orbit, and as it comes round the near side of the Sun, that's this side here. So we can see that Venus is actually quite out to one side as it comes around. Okay, here is a view of our solar system, or our inner solar system, from far out in space. So we can see Earth, Venus, Mercury and the Sun, and if we take a line from the Earth to Venus, we can see that Venus is right on the edge of its orbit as it's coming around the Sun. Planets orbit in the anti-clockwise direction, so Venus has come around this way, and it's actually approaching the Earth in its orbit, so it's getting closer to us. As it gets closer, it's going to get brighter, but there are other factors at play here. Venus is just like the Moon in the sense that it has phases just like the Moon does. So you can have a full Venus, which means it would be on the other side of the Sun. You can have a first quarter, which means it would be out to one side. Last quarter would be over here. Or a new Venus, like a new Moon, which would mean that it would be almost between the Earth and the Sun in a direct line. Of course, we're talking two-dimensionally there. If we're talking three dimensions, it's going to be below or above the Sun in our line of view. When it is in a direct line, of course, that means a transit of Venus across the Sun, as we had a few months back, which is a very rare event. But anyway, that's a side issue, that one. But anyway, we can see that Venus, as it comes round in its orbit, is actually getting closer to the Earth, but the angle that the Sun is shining on Venus is also changing, and this affects the phases of Venus as we see it from the Earth. So let's take a look at that. Now this is the view to Venus at today's date, as seen from the centre of the Earth, so we're not affected by latitude. One thing I am going to do though is I'm going to flip this view horizontally so that it matches our other view that we were looking at here. We were looking out this way. Okay. So here we have Venus. Again, I'm going to turn on the orbit diagram so that makes it clearer, and we can see that Venus is coming around, or has come around from the back of the Sun, and it's on its back way round this way as it approaches the Earth. Remember that we are viewing from the Earth here. Okay, now the other thing I'm going to do is I'm going to turn on the info panel out on the left hand side there, and we can see this is on Venus, so we can see all the data here. It's distance from the observer. Now this is in AU, or astronomical units. 1 astronomical unit is the average distance from the Sun to the Earth, which is around about 93 million miles, or 150 million kilometers. So if you want to work out the distance in miles or kilometers, then you need to multiply the distance in miles or kilometers to the Sun times the figure that we see here, 0.7002, etc. Okay, so Venus is approaching the Earth at the moment, so we can see that this number is getting smaller and smaller as time goes on. Okay, now the other thing I'm going to do is I'm going to center Venus so that we're locked on, and I'm going to zoom into Venus. At the moment it's not showing true size, now it is. Okay, I'm going to turn on a field of view marker for Jupiter at the moment. This is the approximate size of Jupiter the apparent size of Jupiter, that is, as seen from the Earth. This is the angular distance across. This isn't the actual size of Jupiter, it's the angular distance as it appears to be from Earth. Remember that all planets are different distances, so their angular sizes are going to be different depending on their actual distance. So I'll go back to the info pane as we were. Now, this is the size of Venus compared to the current apparent size of Jupiter as at today's date. And you can see how illuminated Venus is at the moment. I'll just zoom in. So we can see it looks like a first quarter moon. We've got 1/2 of Venus illuminated at the moment. But what happens if we go back in time? Remember that Venus is approaching the Earth, it's getting closer to us. So if I take time back, we can, what do we see? We see that although more of Venus is illuminated because of the angle of the Sun, because it's further away from us, it's actually smaller. Okay, and remember, I'm just showing Jupiter as a comparison. That's the yellow circle. Okay, so by the time we get back to when Venus was on the other side of the Sun as seen from the Earth, we end up with what is equivalent to a full moon, or a full Venus in this case, where we have the whole disk of Venus illuminated. Down here you can see it says disk illumination 98%. So if I take that back a little bit further, 99, 100%. So here is a full Venus, if you like, and this is when it would have been around about opposite the Earth on the other side of the Sun. Okay, but look how small it is. Now let me flick this back instantly. If I hit the Now button, you'll see the difference in size. Although we've got a full Venus here, this is what we see right now. Okay, so I think this makes it clear why Venus is looking so bright at the moment. And as it gets closer, it's going to get apparently bigger as well. Obviously the actual size of the planet doesn't get bigger, but as it's getting closer, it's bigger in our sky. But unless you're zoomed up on it like we're seeing here, you don't actually perceive just how much bigger it is than what it was some months ago. Now after the crescent gets quite thin, you can see how big it's getting here. But that crescent of light, I'll just zoom out here a bit because it's so big, that crescent of light, the illuminated area on Venus, is getting thinner and thinner. So although it's going to get very, very close to us, around about, where are we? About 10th, 11th of January, it's equivalent to a new moon. In this case it's a new Venus. So it's between the Sun and the Earth. So we won't see it, obviously. But as it approaches that alignment, then we're going to see less and less illumination of Venus, and it's going to get dimmer. But for now, if I hit the Now button again, as we can see, it's pretty well illuminated. It's like a first quarter moon, and it's going to get closer and it's going to get brighter. Down here you can see the apparent magnitude. Okay, at the moment minus 4.49. Let me check it again today. Minus 4.37. Now with these numbers here, the brighter the object is, the lower the number is, and that includes with a negative. So an apparent magnitude of minus 4 is considerably brighter than an apparent magnitude of 4, or that is plus 4. So the lower this number goes, the brighter Venus will get. So again, if I step the date on, you can see that number is getting lower and lower. I just hit months there, let me just take it back. Getting lower and lower. As a minus number, that figure is getting bigger. It's heading the other direction. So we can see that, where are we? 4.6566, 67. Okay, so around about December 14, Venus is going to be at its maximum apparent magnitude of minus 4.66, and then after December 14, 15, it's going to start heading back the other direction. It's going to be getting dimmer. So I hope that explains why Venus is looking so bright. It's simply because it's getting closer to us in its orbit. As we can see here, it's approaching the Earth, and as the Sun is shining on it and it's getting closer to the Earth, it is going to get brighter. It's quite normal. It's something that's been going on for millions of years, billions of years, and it's nothing unusual. As always, do check out my Facebook discussion page, Voices of Reason to Explain X, or VORTEX. I'll put a link in the description area for you. Thank you for watching. Hello YouTube, this is Dazza the cameraman. Today is Monday 28th of October 2013, and today we're looking at the question that a lot of people are asking at the moment: why is Venus looking so bright? Some people feel that Venus is looking unusually bright and that there's something wrong, and that there's something that the government isn't telling us and all this sort of thing. So we're going to take a look at Venus today and see if we can figure out why it looks so bright at the moment. As you can see, I've got Starry Night Pro set to Dallas, Texas, United States. So this is a Northern Hemisphere view of Venus, and I've set the time at 7:30 p.m. This is daylight saving time, and we can see Venus here in the sky. Now we're looking due west here, so we can see that Venus is in the southwest at 7:30 p.m. as seen from Dallas, Texas. Now sometimes it's hard to actually visualize what's going on as we see things in space, so what I'm going to do is turn on the orbit for Venus, and this will hopefully make things a little bit clearer. Now we can see Venus's orbit around the Sun. Remember that we're the third rock out from the Sun. From the Sun we've got Mercury, then Venus, then the Earth. So we've got two planets' orbits within the orbit of the Earth. So here is Venus, and you can see that this line here is the far side of its orbit, and as it comes round the near side of the Sun,